All right, y'all. I'm sorry. I'm continuing from number 13. All right, so I'm putting my data into my list. Here we go. 4, 2. Remember, I don't have to worry about the order because the calculator is going to put that in order for us. 7, 6, 8, 3, and I'm on number 13, guys. Alright, I noticed that I have my next cell is 21, so that means I should have 20 data points in there. Alright, so now I'm going to press Stat again. Now I want to go over to Calc. I want option 1. I only have something in one list, so I don't have to tell it what list to pull from. So I'm going to press Enter. Remember, this screen gives us several pieces of information. Here we have, if we needed the mean, we have it. Here we have the total of the numbers. Here we have the sample standard deviation. Here we have the population standard deviation. But I'm going to scroll down because I want quartiles. Q1 is 2. I'm going to remember that. Quartile 1. The median, which is also known as quartile 2, is 4.5. And here's my quartile 3, 7.5. Okay, so we're given that information. So I'm going to go back to my notes and let's write out those keystrokes once again. So the first thing I did was press Stat. Option 1. Enter data in L1. Then I press Stat again. I want to tab over to Calc. Option 1. And scroll down to record Q1, the median, which is also our Q2, and Q3. Okay. Alright, now for part B, it says choose the correct plot below. Note the different technologies will produce slightly different results. Well, we really won't use our technology for this part. We're going to use what we have. We saw from a previous problem that here's our box. These are our whiskers. Based on this box and whisker, the middle line in the box should represent the median. That's what I'm going to use to test which one of these is my correct visual for this data. Well, let's go right here to B. Do you notice how B doesn't even have a line in the middle? So it's really saying that there is no median, and that's not true. So B is not my answer. It does not show a median, and there exists a median for this data set. It's 4.5. Well, that means I'm going to look at these others and see, do they display 4.5 as the median? I'm going to use my ruler, and I see this median. I'm just going to extend this line real lightly. Well, this is 3. That means this is 4. This is 5. That's about 5.5. That's not what we said our median is. This median, this answer is not correct because the median is wrong. Let's look here. In answer choice C, I see that the median is here. Well, that's 3. That's 4. That's 5. Oh, that lives right there in 4.5, which is exactly what we said our median is. This has the correct median. Not only that, it also has the correct interquartile ranges. Quartile values. So according to this answer choice, quartile 1 is right here at 2. That's quartile 1. That's what we said. According to this, quartile 3 is at 7.5. Here's 6. That's 7. This would be 8. So this would be quartile 3, which is at 7.5. C is my correct answer. Notice how I was able to see my median, or quartile 2, and quartiles 1 and 3 all in this box and whisker. Alright. Please feel free to pause the video at any time so that you can replay or rewind whatever you need to hear again. Let's go to number 14. Alright, in number 14 we have a new variable, or a new we'll call it variable, the use of a new Greek letter. We'll talk about what that is. It says the table shows population statistics for the ages of Best Actor and Best Supporting Actor winners at an awards ceremony. The distributions of the ages are approximately bell-shaped. Compare the z-scores for the actors in the following situation. Now, a couple things. This first statement just tells us about the problem. This is the context, what they're talking about. But this second statement, the distribution of the ages are approximately bell-shaped. We call that symmetric or normal distribution. So approximately bell-shaped. That's symmetric. You may also hear normal. That just tells us that it takes on that the shape of a symmetric type of distribution. Now, in this information here, we have this symbol mu, pronounced mu, M-U. Okay. It's what we call our population mean. Okay. So mu, I'm going to put that over here. It's kind of like the letter U, but with the longer front part. It is pronounced mu, and it stands for our population mean. We already know what this one is. This is our population standard deviation, sigma. Okay, so here's what we have. We know that the mean for the best actor's age is 46. Remember, mean is like the average, so all the best actors are around 46 years old. The best supporting actors are all around 4 years old. They deviate from the ages deviate from the mean age, or the average, at about 8.6 years. Okay, they deviate from the best supporting actor's average about 14 years. We've been asked to compare their z-scores for the actors. Well, there's a formula for that. Okay, so to calculate a z-score, that's what I'm going to put here. To calculate a z-score, what's going to be important is that you remember what you're given. So this problem gives us, given the population mean and standard deviation. So I'm going to use this formula when I'm given this piece of information. So we use the formula Z equals X minus mu divided by sigma. In words, we're going to take our given value subtract from it the population mean and we're going to divide it by the population standard deviation. Okay, so let's see that happen. So we have a population mean of 46 and a standard deviation of 8.6. It says in a particular year the best actors was 38 years old. That's going to be our X, y'all. That's going to be our given number. And then the best supporting actor was 58 years old. That's going to be our X as well. So let's calculate. For the best actor, we're going to do Z equals the given value, which is 38, minus the population mean, 46, and we're going to divide that by 8.6. So 38 minus 46 is negative 8 divided by 8.6. And so negative 8 divided by 8.6 is about this number. The problem says we need to round to 2 decimal places as needed. So to round to 2 decimal places, which would be here at the 3, I look here at the next place value, which is a 0. Since 0 is not larger than 5, this is what I'm going to record. Okay, negative 0.93, or I'm going to record it this way, negative 0.93. Let's do that for best supporting actor. So Z is equal to the given value, which is 58, minus the population mean, which is 54, divided by the standard deviation, population standard deviation. So Z is equal to, go ahead and subtract 58 minus 54. We should get 4 divided by 14. And the approximate value there, my calculator, I'm dividing 4 divided by 14. I need to round to 2 decimal places as needed, so I'm going to look here at the 3rd place. 5 will bump this 8 to a 9, so I'm going to record 0.29. Okay, and that's how I calculate the Z score. given the population mean and the standard deviation. Right, let's go on to number 15. Oh, I'm sorry, that's it. Alright guys, that's the last for 2.1. You'll also see a video for the homework for 2.2 in a moment. Have a great day.